So as you can see here, this is a portable fan, and it is controlled by the Arduino or microcontroller. So in this video I will show you how to turn on and off this fan here or any DC motor, and also to control the speed of this motor here by using Arduino. So if you want to know how to do that, so please check out this video. This is the DC motor. So if you have this DC motor, you can explore this DC motor here, and if you don't have this DC motor, so you can get one. And as you can see, we need to solder this cable here into these two ports here. So if you don't solder it yet, so you can solder this two cable here. If you don't solder it, it might lose, and therefore it might not give a correct functionality. But if you just want to try, for example, if you don't know the polarity of the motor yet, so basically you can just try to just tie the cable onto these two ports here without soldering it. But if you already know it, if you already know the polarity of the motor, then you can directly solder it. So this is the DC motor which I have already connected to my circuit here, which is following this circuit in this Tinkercad here. So you can refer to this Tinkercad here if you have hardware in order for you to construct or to complete this motor, this circuit for this motor here, which is it has this capacitor here, and then the diode, and then the NPN BJT bipolar junction transistor, and also this resistor, the 1 kilo ohm resistor. And as you can see here, it also has this 9-volt battery. Why we need this 9-volt battery is because if you still remember what I have mentioned in the beginning of the lecture, or in the introduction lecture, which I said the output from this Arduino have a lower current, and that's why most of the motor requires higher current, and sometimes requires more than 5 voltage to operate. And that's why we need extra power supply here with 9 volt and up to 12 volts, which if you want to make sure that this motor here can turn at the maximum speed. Without this power supply here, actually it can still turn, but it cannot turn at the maximum speed, and that's why we need this power supply here to give enough current for it to operate. So if you don't know about this output, the current of the from the Arduino output, so you can just again refer back to the introduction video that I will also attach the link down below. So again, just watch the introduction video if you want to know how many current, the maximum current that this Arduino can supply. And that's why again, this is why again we need to use this 9-volt power supply here. And this is, if you have hardware, you can directly follow this construction here, but make sure that you connect this diode and also this NPN BJT transistor with the correct polarity. If not, then we cannot operate, especially this transistor here. Make sure the collector terminal is connected to this motor, this base terminal connected to this input, the output ports, which is at the port 3, and also the emitter is connected to the ground. So make sure the connection is correct. So if you don't know how to read the terminal of this NPN transistor, you can refer to this figure here, which the flat parts, which means that you need to look at from the flat side, and then the first terminal, if you look at from the flat side, so the first terminal is the emitter, and then base, and the third terminal is collector. So make sure you check it, make sure you read the terminal correctly. If not, then it won't operate, or basically you can't get the maximum rotation. And that's why if you connect it wrongly, so it cannot operate as what we desire. And please make sure this connection is correct. Please make sure you read the terminal correctly. So you may pause this video as usual at any parts if you want to construct this circuit here on your breadboard. So you can take your time, you can pause this video, and let's say if you don't really understand this circuit in this breadboard or in this Tinkercad here, you can always go to this Proteus here. So this is the schematic circuits for this the same circuit that I shown in the Tinkercad just now, with the 1 kilo ohm resistor, the 2N2222 transistor with the emitter at the ground, and then this DC motor here, and then the capacitor with 1 microfarad, and also the 1N4004 diode. So again, make sure the connection is correct. If you want to find the diode, so as usual, just go to this part, just search for 1N, search for this number here, 1N4004. So it will directly go to this diode. So just choose this diode, and then you can construct here. And for the motor, there are two types of motor that you can choose. So we have just search for the motor. So if you search for the motor, there are several motors. So you can choose the motor with active, so that it can rotate whenever you run the simulation, this one here. And also the motor DC, either one, you can choose either one. So here I use this motor DC here, and if you want to use this motor here also, you can use it. But make sure if you use this one, you might need to change the revolution here, the rotation, the nominal revolution here, to higher value if you want to change, or if you want to look at the different speed later on when we try to control the speed, let's say up to 100 revolution, for example. So this is if you want to use this motor here, but I choose this one more motor here, because it can display the speed when the motor is turned during the simulation, and that's why I choose this motor here. But this motor here has inertia. So when we say inertia, if you have learned in the physics before, the inertia will, when you stop the motor, it will not directly stop the motor, and when you start the motor, it also starts slowly, and this is because of the mass on the motor. And that's why if you use this motor here, you need to change this component properties. You might need to reduce the mass here. The default mass is 0.01, but now I just reduce it into 0.001, so that the mass effect is not there, and it will directly stop when I want it to stop, and when it will directly move when I want it to move. So this is if you want to use this motor here, you need to change the effective mass. If you use this motor here, so you use this motor here, so you need to change the revolution, maybe 100, up to you how fast you want it to show. So this is two things that you need to consider when you use this Proteus for your simulation. And why we have this capacitor here? This capacitor here basically to filter out any noises comes from the motor, because motor rotation is not constant. So that's why we need to remove any spike from the motor by using this filter, the capacitor. If you don't know about filter, basically it is covered in the analog course, so make sure you pay attention into the analog course later if you want to know more, if you don't understand why this can become a filter. And then we have this transistor here, so that this transistor here basically to control the current that permitted to flow into the motor. And because of when a sufficiently high voltage is applied to the base here, what happens is current is allowed to flow through the transistor and the motor will spin. In other words, it will act as switch. In this part here, this transistor here will act as a switch. If the voltage is not enough or the current is not enough that is supplied on the base terminal here, so the motor will turn off. And because of that, because we have the currents is changing, so basically we can control the current that comes out from this ports here, which means that basically we can use the PWM to control the motor here. The higher the current or the higher the voltage, basically the higher the motor movement later on. And that's why again we use why I connect to this port 3 here, because this port 3 here is a PWM port, so that later on I can use the PWM function in here so that we can control the speed of the motor. And this diode here, as you can see, we connect it in reverse bias. Why? Again, because this diode here, as we know, it allows current flows into one direction only. So when current comes in here and allow the motor to move, so this current can flow. But when the DC motor spins, energy is built up and stored in the inductance of this motor coil, because we know this motor has coils inside it. And if, let's say, if you instantaneously stop the motor or remove the power from the motor, the energy is dissipated in the form of inverted voltage spike. In other words, when this motor is suddenly stopped, this current will be a spike current will feed back again into the motor, which will break the power supply here, and this is dangerous. And that's why we use this diode here in order to protect this power supply here from the feedback currents or the spike currents that comes from the motor whenever the motor is suddenly stopped. Because basically when we control the motor, sometimes we need to stop it suddenly because we want to basically we want to change the direction, for example, and this kind of activities can cause this spike current here, which could cause this could destroy this power supply here. And this is why we use this kind of setup circuit here. If you don't know why we need to have this kind of circuits, although basically we can just connect from this ports here, directly connect to the motor, and the motor directly connect to the ground, and it still can operate if you try, but basically it is quite dangerous when you stop it directly. And basically this spike current, if you do that, basically it could also break your Arduino, and this is why we need this protection circuit when we use this motor here. Alright, so this is the setup of the motor of the circuits. If you want to use Arduino, if you want to use the Proteus, I already show you how to get all these components from the component library and to construct it. And this C motor here, as we know from the see from the Tinkercad, so you need to set it into 9 volt. Make sure you edit the properties of this VDC to 9 volt. Don't let it 0. Make sure you change the voltage here. So this is if you want to use Proteus. If you want to use hardware, you can follow this circuit here. Make sure again the transistor is connected correctly. So this is the setup. As usual, you can take your time to complete the circuit. So again, any methods you want to follow, the hardware, the Proteus, or the Tinkercad, but make sure you try to do it. Take your time to construct it, and whenever you're ready, then you can proceed with the next video. So basically I will stop here for now. Then you can finish up the circuit, construct the complete circuit, and now you may proceed with the next video. Hope this video helped. And again, if you like this video, please make sure you click the thumbs up button down below, and don't forget to subscribe. And again, that's it from me for today, for this time around. I am Ikhwan. May God bless you. Assalamualaikum.